So they used to be washed and washed. So very few people used to visit that tea shop because people had a hygiene issues. Okay, because the glasses were not properly washed. Now you can, if somebody offers a tea at that stall, you would easily accept that invitation because you know it would be served in a some disposable material or utensil. So hygiene is not an issue. Now we have industry 4.0. So this is a very complex structure. So don't worry, I'll be taking each part one by one. And in some of the slides you'll see that something is common, means common. So that common helps you to make association in your mind that what is going on. So if I talk about industry 4.0, there are 5 things. First is integration of technologies. That is, you have AI, you have IoT, you have cloud, okay, and you have big data. So 4 major means technologies are there. And in real-time monitoring, because IoT devices are collecting data, okay, and data analysis is being performed regularly, repetitively, without human intervention, okay. So that gives you the data analysis part. Then with that data analysis, you can make decisions. You have strategic choices, market responsiveness, okay. So you can respond to the market very easily. And we have smart factories. Those are basically cyber physical systems and with lots of things automated. Now, this gives us self-optimization. That means process improvement and efficiency gain in the total production chain. Clear? I hope there isn't any doubt. So this is a complete picture which we will be discussing today in Industry 4.0. Okay. Now, let's start with the basic things. Now things are connected. Things are connected. For example, a machine is making a production. Okay. Suppose you have a simple drop example of machine. Imagine fan. You have ceiling fans in your college, and each ceiling fan is communicating with a central server about its health. Okay? And since the data is being continuously received by the central server, it can keep an eye that which fan needs maintenance. So that before things go out of hand, somebody can come, take that fan off from the system, repair it, grease it properly, and then put it again, install it again. So things never break down. And this preventive maintenance can be done after the classes, so nobody gets disturbed. No complaints in the system. The fan is not working. So this kind of things are there in the real industry. So, and that can only happen with the basic thing that if machines communicate, okay? And then the automation executes the task. So if machines can communicate, we can monitor their health and we can automate things. And intelligent devices, drivers, smart decisions making in Industry 4.0. So we have machines, automated systems, devices, and sensors and people. So we have machines, devices, sensors, and people, 4 components. And that 4 component gives us integrated manufacturing environment, seamless connected production system for enhanced efficiency. So we have better efficiency. Imagine a scenario, a company is producing something, some item, let's say something, and for example pen, it is being produced by the machine, and all of a sudden on one fine day machine breaks, it halts. So entire factory sits idle because machine is out of order, and in that situation you have to call a mechanic for repairs. Repair will take its own time, and till that time your entire production is halted. You incur losses, you are out of the competition day by day, hour by hour, because somebody else is actually fulfilling that gap, because your production is not in the market. But if that machine is able to communicate to the person that okay, I am not fine, I need repair and maintenance. Okay, so that will help us to actually better manage the production system. Oh, okay. Integration of physical and digital. So we have physical machines that is working with tangible components. Then we have digital technologies, software and computing elements, sensors, devices that gather real-world informations, computer systems and software and computer systems, brain that processes the data and controls the machine, hardware and software interaction is there, and then it results into smart factories and industry 4.0, the application and future of CSPs. Okay, so this is how it moves: physical machine, digital technology, sensors, softwares, and hardware software interaction takes place, and then finally you have a smart factory. So you move from in a clockwise direction and you get a smart factory. So these are the basic things that will happen, and they are happening actually. So real world interaction cycle, how it happens? So we have a data exchange, that means continuous flow of data is there. We have monitoring and analysis. These are automated systems which are monitoring entire factory. Then we have instant response to problems. Okay, so your response team can actually suggest pre-propose some solution for some problems which are frequently occurring. And then you have decision making and automation. So this is a cycle how industry is actually maintained. Let it be any industry. So this is how it be maintained. So now I've talked about 5 components. The first component is IoT. IoT means that there is a device, it has some function, it has some presence in the environment, but it has one more feature, that it is connected, it can pass on its data and receive the commands also. So that's it, basically Internet of Things. You have a smartwatch that is actually monitoring the number of steps you walk today. Okay, and if you send that data, you want to send that data from smartwatch to some cloud, you can easily do that. You can receive communications, you can check your emails, you can have messages. So that is smartwatch. It's a wearable device. Similarly, if a machine is making something, so you know, machine which is engaged in production will have moving parts. So if a machine is going out of order, so all of a sudden the vibrations will increase. There are we are lucky we have person from mechanical and electrical department. Sir can easily understand that things in mechanical means motion, rotatory revolutionary motions controlled by electricity. So if something is going out of some bearing or some bush is out of order, so all of a sudden sound will increase. Now the sound sensor, which is actually continuously recording the machine sound, can suggest, can record, can measure the smallest change in the vibrations, and that is being sent to the software for analysis. Software filters out what the problem is. It can even locate where the problem is. In IIT Kanpur, in way back in 1994, so there was a student who was working on preventive maintenance. So he identified, he recorded the various sounds of the moving parts of the machine, assembled the entire machine, and then he can figure it out that which part is actually will go out of order first. Clear? Because acoustics were being analyzed. So this is how you can do. So what happens is that we have an IoT device, ecosystem is, we have a wireless network, smart homes, connected cars, industrial machines, wearable devices, and cloud platform. So data from all the devices comes to cloud platform through wireless networks. And on the cloud, we can keep the intelligent softwares which are actually monitoring the device data. Clear? Suppose if I give everybody a smartwatch with some program installed in it, and your principal calls up in the afternoon that, sir or madam, you have not even taken 100 steps today. Please, it is mandatory for college that you take 500 steps, go to the park and walk and come back, so that your health, your body functions properly. You do not take CLs, okay, you never fall sick. So that is what a preventive maintenance. Similarly can be applied to machines also. So now we have big data analytics. It's a very big topic, but things in a simple way. We have data ingestion, that somebody is collecting the data. Data is collected over here in this. Now data is processed. The collected data, let's say 100% is there. After pre-processing, you have 80% of the data. Then you analyze the data. That means you have 60% of the data. So every step you are removing 20% of the data. Now we have data analysis, and from that data analysis, only 40% of the data will be used for making a decision. So this is how big data or data analytics works. So this inverted pyramid shows that the amount of data is received on the top, then it is being reduced to every step at 20%. This is the, as per the stats suggest us. Now cloud computing. See, cloud computing is nothing. We have a set of connected devices which can remotely access. We have a cloud storage that no need to bother where your files are. And then we can do data processing. So cloud has one advantage. You keep your files in your laptop. What happens if your laptop is out of order? Okay, so those who have recently purchased a laptop, they say that when you log into your system, it asks for Microsoft ID. Okay, OneDrive. So whatever files you make are automatically shipped to the cloud platform. Your hardware goes out of order, do not worry, throw it off. Your data is intact in the cloud. As soon as you log into the new hardware with the same ID, you can pull down your data. So this is the advantage of cloud. No need to worry about your data backups, everything is intact. Whatever you have created, it is there. Employee comes and leaves. Whatever work he or she has done is retained with the organization. No need to ask for that, where the file is, what is the name of the file, file has been corrupted, file not found. These issues are all together taken with the help of cloud. Okay, simple, in simple terms, cloud. Now artificial intelligence, the word is talking about it. So artificial intelligence or machine learning is nothing. If you have the data, you can pull out some numbers, you can put analysis, you can do some analysis on that number, draw some decisions and conclusion, and that is what artificial intelligence is all about. So what you need is data nodes which can actually provide the data. Okay, then what you can do, you can apply your machine learning algorithms. Okay, what you can do, you can prepare charts and graphs, and you can make predictive system which will predict. If you have traveled to the Volvo bus, okay, in computers, if you open your power on your desktop, there is one message it comes like post. What is the meaning of post? Can somebody tell? Because most of them must be from the computer science background.
Power on self-test.
Yeah, power on self-test. If you travel to Volvo bus, as soon as you put on your ignition, it also do the post test. If something is out of order, the Volvo bus would not even move an inch, and that is why people trust to travel in Volvo. That you are traveling from Lucknow to, let's say, Delhi, so your bus will not be down, okay, somewhere in between. It will be on the station itself, it will refuse to start. So that is the technology in Mercedes-Benz and Volvo buses. Clear? Your new age cars, they also do all kinds of post test. If you are less on the engine oil, they will not start. They start give you warning. Okay? Clear? So this is what post is there. Means it is, you are working with them, you are riding on them, but you never come to know about their means true, use, utility. So these are actually using some kind of algorithm, and those kind of algorithm are not basically the pure machine learning algorithm, they are proprietary algorithm of that organization. Okay, and but they are working as a predictive systems. They tell that, yeah, we can take 500 kilometers of ride on this bus or in this car, nothing will happen. Okay, and in Scorpio they can also analyze the tire pressures. If your 3-4 tires are there, one tire is or less on pressure, it will give a warning that tire number 3 is having less air pressure. So you don't have to actually